In part 1 of OSPF IPv6, we looked at the original or the old way of configuring IPv6 with OSPF. Here we'll look at the new way of configuring it, and we'll configure both IPv6 and IPv4 on our same network. So the big thing to know is with our new way, we can run both IPv4 and IPv6 families in the same process. We'll have a single database and send out IPv4 and IPv6 information. They'll create their adjacencies or have a separate adjacency database for each. The thing to know about OSPF v3 and the new way of configuring it is that it uses IPv6 only for transport, or it only uses IPv6 for transport, which means it's not compatible with OSPF v2. So when we think of ourselves, we think, okay, we run OSPF v3 in our new way of doing it with our address families, and maybe I'm running IPv4 on router 1, and I'm running IPv4 on router 2, but I'm not running OSPF v3. I'm running the original OSPF. They actually won't communicate with each other because OSPF v2 uses IPv4 as its transport mechanism, whereas OSPF v3 uses IPv6 for its transport mechanism. So just a couple things. Well, let's go ahead and look at how they're different. Here we have the new set of commands. Still on both sides we have to use IPv6 uniguest routing. The way we create the process is different now. Now we use the command router OSPF v3 and then give it a process ID or process number. Whereas when we did it previously, we did IPv6 router OSPF and then a process number. Router ID command is the same. What we will discover is that I can do the router ID under the process with OSPF v3 in our new commands, or I can do it per address family. So if I want a different router ID for our IPv4 that's running versus our IPv6, I can actually do the router ID separately under the address family. And then we go ahead and enable OSPF on the interfaces. So notice the commands here again are a little bit different. Our old way was IPv6 OSPF process number, then area, then the area it belongs to. Just a little bit different here. Instead of this portion here, we'll do OSPF v3, the process number. Choose IPv4 or IPv6. What do we want running on this interface? The area, and then the area we want it to run in. Okay. So we'll go ahead and configure it. They're not that different, but they have OSPF v3 in our new set of commands. Like I said, allows us to do both address families. And so we can do a couple other things differently and not have to do them twice. So here's the IPv6 topology we're going to be working with. I've already configured all the IP addresses. I've already configured all the IPv6 addresses. I want to create two separate areas. So over here on this side, I've already configured all that. Oh, actually I configured the IPv6 address here also. So the only thing you're going to have to, instead of us doing it 3 times, is we'll configure this part and demonstrate the new way and then verify our various tables. Check that out. Alright, so I brought branch over here and I've made it so we can still sort of see the part. Remember, I've already configured all this. We're just going to configure this part and watch our neighbor relationships come up and watch routing happening. So with our new commands, same command, right? The original command is the same. IPv6, wow. Unicast routing. And then we want to create the process. So router OSPF v3, the process ID we'll use is 1. Here we have to give it a router ID. This is no different than the previous way we had done it. The router ID is a 32-bit value written like an IP address. And since on this router I don't have any IPv4 running, I've got to configure router ID specifically or explicitly if I want the process to run. So router ID, the first router, so we just use 1.1.1. Not all that creative. Let's go to interface. So our int gig 0 here. I'm going to make them all run IPv6. We've already done the demonstration to show that if we don't activate on a particular interface, then it won't run on that interface. So I'm just going to do it for all of them. OSPF v3, our process is 1. We're dealing with IPv6 right now, and our area that this guy is in is 0. Look at that. And you can see that we created our adjacency with HQ. Now, I'm going to do all my loopbacks at once, so I should be able to do an int range, LO0 to 3 of them. Do I have 3? No, 0, 1, 2. So I have 2. And again, OSPF, or we can just hit the up arrow. I just wanted you to see it again. So again, OSPF v3 processes 1, IPv6 area that the loopbacks are in are 0. And that's all there is to it. Okay. And show OSPF v3. And here we can see our address family version 6, our router ID. Let's do a show IPv6 route. Pull this down just a little bit. We have our OSPF routes. This here is the other side. This is over here. It's the other side of HQ, between HQ and branch. And where do we have? Here's the loopback on branch 2. So we're getting routes, and we've configured it successfully. Let's go ahead and do a show. What did I want to look at? Neighbors. You'll also notice here, type show correctly. Tab completion is your friend. I'm trying to type just so that I'm slower. So I slow up a little bit for you so you can read stuff. We just look at our neighbor, and our neighbor is his neighbor ID is 192.168.2.1. And the reason why is because I configured both IPv4 and IPv6 on HQ and branch 2. No reason except for to demonstrate that they can run at the same time, and we'll go ahead and configure that on branch 1 here in a minute. The other thing is, what this tells me too is that I didn't explicitly, or what I didn't do, because I know that's the IP address, I didn't explicitly on those two configure a router ID. If you're running IPv4 along with it, then you can go ahead, or if you have an IPv4 address on the router, then it will go ahead and choose the highest loopback interface IP address or the highest physical IP address. The other thing to notice is the commands you used to use don't work the same anymore. So if I do a show IP OSPF neighbors, I'm not going to get any because I'm not running OSPF v2. So you'll notice that the commands that we used to use to get the same output don't work the same anymore with the new way. Now let's go ahead and let's do a show database. And here we can go ahead and see a router ID, the address family we're running, and all of our various database information. Now let's go ahead. Now we have IPv6 running all the way through the network. I should be able to, I want to ping FD01:4. We ping the IPv6 address of the loopback over here. So we're getting all the way through our network, and we're able to ping IPv6. So IPv6 is running wonderfully. Let's go ahead and add IPv4 on there. All right, so remember what I told you is I pre-configured this area here. And here are the IPv4 addresses that we're going to work with. Oh. .1. That's .2. This will make more sense in a second. .1. .2. And the network address for this link is 192.168.1.0. So this guy on this side is 192.168 1.1, 192.168, 1.2, 192.168, and this side is 2. So we'll go ahead. I keep touching it. Hold on. All right. So 192, 168, 1.0 for this link. So then this guy's .1, this guy's .2. On this link, and I've already configured this link, remember, 192.168, 2.0. And then down here, I have done IPv4 addresses. So, and I've kind of had them pretty, you know, if this guy was 4, then I made this guy 4. So 192.168, 4.1, all/24. So we'll go ahead. I haven't configured them yet. Why don't we just go ahead and we'll do it together on this side. I haven't put any of the addresses. I know you know how to do it, but let's just do it real quick. So it's int 0/1. The IP address here then, whoop, 192.168, 1.1, 24-bit subnet mask. Oh. IP address on loopback 0, which would be this first guy. So this, it goes 0, 1, and 2. He's 3.1. This guy right here is going to be 5.1. And this one over here will be 6.1. Let me just up arrow to get there. So now our IPv4 addresses are configured. Now all we need to do is configure routing for IPv4. So any interfaces that I want to participate in IPv4 routing, then I have to configure that. And it's the same command we used for IPv6 to activate it. The only difference is we specify IPv4. So we're already, let's go int gi01. Let's go on our gig01, and we'll activate him because then that should start the process throughout this network for 4 then also. OSPF v3, 1 is our process, IPv4, area 0. Now let's see if I did a good job on the other side and actually configured them all correctly. We should be able to see. There. Uh-oh, I missed something on the other side. Let me check. I'll come back. Actually, what happened, I just decided not to do it. So I went to show, run. I didn't configure it. So if I just go, the first time it sees gig 0.1, you can see that I configured the IPv4 address over here in branch 2, but I didn't enable it for IPv4. So it's not going to work. Well, let's just go ahead and do it then. So we did our gig in branch 1, right? Let's go to HQ. OSPF v3, the process. Gig 1 is in area 0, right? Oh, forgot to specify the address family. And now you can see that our adjacency then came up for IPv4. Oh. Let's make sure we're in the right spot. Now I'm just going to up arrow and change this to area 1 because that's this link over here. And then we'll go back into branch 2. What's kind of cool about branch 2 is every one of them, each interface is configured exactly the same way as far as they're all in area 1. So let's go ahead and do int range. No, we can't do int range. Sorry, I was thinking I had more than one on there. I could do that on the other side though. Int gi0/1. area 1. We'll put loopback 0 also in our OSPF process. So now we've done it. We have activated our interfaces on HQ and branch 2 to run IPv4. Go ahead. Did I ever finish up over here? No, I didn't, did I? I don't remember if I did. Oh, I only did the one side. That's right. I only did gig 1 on this side. So now we should be able to do a show. And we see our IPv4 routes. There we go. I was looking for a second. If you notice, the first time I was just a little too quick for it. I didn't have that 4 network over here. Now we do. I was a little worried for a second. There's our 4 network. All right. Now, but if we go over to branch 2 and do a show IP route, all we see is the 1 network because I didn't put any of the loopbacks into IPv4. Now, if I did a show IPv6 route, I will see the 1.1, the 3.1, the 5.1, and the 6.1. So we're running 4 and 6 together under the same process. I'm going to go back. Let's just go ahead and configure it. Here we can do it in range because all the interfaces are the same type. 0 to 2. OSPF IPv3. Process 1, IPv4 is our address family, area 0. And now they're all in there. If we do a show run we're going to begin at router. That'll be the first time. So router OSPF, now you can see here's the routing process now. What I wanted you to notice is that we're running both sets of address families under the same routing process. So I didn't have to do router OSPF 1 and then separately do one for IPv6. We run them both. Now, if there's specific things that you want for the particular address family, you'd configure that under the address family. So we'll just do one. So for example here, these are all loopbacks. But I put the computers there just to simulate, okay, I've created loopbacks so that when I do these demonstrations, I've simulated that there's more networks to see. So there'd be more routes to see. But let's pretend for a moment that, in fact, connected to branch, each of these interfaces is a switch. And then on the other side is a whole bunch of users. If that's the case, if the other side is just a switch and a bunch of users, then I don't need to be running OSPF. If this is just a layer 2 switch and all I'm doing is connecting my users out to the rest of the network, then I'm not running OSPF over here, right? Gotta make sure I have my pen. Oh, I don't have a pen. So if we say that this is just, I'm doing some layer 2 switching here, and I'm just providing these guys with access to those networks and to be able to get out. Maybe they're getting out to the internet, who knows. Then I don't need to be running OSPF here, right, between my router switch, because he's not recognizing it anyway. If there's no OSPF on the other side of this, I don't need to be running it. So why don't we then just go ahead and we'll make these interfaces passive. That way they won't send or receive hellos off of the interfaces themselves. These guys over here, it's part of the routing process, so branch over here will learn about each of these networks, but between these interfaces, or right off of this interface here, if we make them passive, then they won't send or receive hellos. All right, this specific to the protocol, we can go ahead, we'll go in the address family and do this one. We'll make we'll just for the sake of demonstration, we'll do it specifically for IPv4. I mean, we'll do one on IPv4, one on IPv6. Anyway, First thing you want to do is go into the routing process. So router OSPF v3, process 1. Now we want to go into the address family. Address family IPv4 unicast. I'm just going to hit a question mark here. You can see this is where all the things specific to the IPv4 address family, where you're going to configure those. Configure authentication for IPv4. We could configure default information. We could configure maximum paths over that. We are going to configure passive interface. So we'll do passive dash interface. Let's hit a question mark. Here's where I get to pick my interface for our instance, because they aren't, real. They're just loopbacks. They're not real. We'll just do loopback. So we can do passive interface LO0 and hit enter. Okay, so oh shucks, didn't want to do that. Didn't want to do that either. Show run begin passive. So it starts showing me the first time it saw the word passive. Shoot, I should have went just before. So router OSPF v3, notice that this router ID, it's the router ID for both IPv4 and IPv6. Our passive interface command under IPv4. I could also take this router ID specification off and do a separate router ID for each of them. At this point, because I'm running IPv4 and IPv6, I can take it off, clear the process, and it will actually choose the highest loopback address. Let's just go ahead and do it. And it actually will tell you to go, you have to clear it. And it's kind of interesting, you get a message for both address families, which is kind of neat. So let's go ahead and clear OSPF v3 process. Whoops. In the wrong spot. Should have known better. You don't do that stuff automatically. Clear. Click yes. Now we clear the process. Let's do a show OSPF database. Oh, no. Remember I said we can't do that anymore. Well, let's do it. Oh, that's right, because it does one for each. I'm like, wait a minute. Thing I want you to notice is your router ID has changed to our highest loopback. Show you could also do an OSPF v3 statistic. You could see how many times the shortest path first algorithm has been calculated for area 0. Again, router ID is what we're looking for. Just another way of getting that information. All right, I could go on and on forever, but I think this is probably good enough. This is plenty long. So we looked, let's go back. We looked in the previous at the old commands. Here we looked at the new commands. We also verified that, in fact, with the new set OSPF v3, router OSPF v3, we can run both address families, version 4 and version 6, IPv4, IPv6. Big things to remember that when we use this command, it uses IPv6 for transport as its transport, which means it's not like backwards compatible or compatible with OSPF v2, so that's pretty important. Also remember, if I'm only running IPv6, I still need that router ID because it's still a 32-bit number. And I think that's about it.